The current state of the nation's critical infrastructure is at risk. The Internet has become the central nervous system of the nation, both private and public. The nation's critical infrastructure continues to be vulnerable to natural disasters and cascading cybersecurity attacks. In fact, software has become the critical infrastructure within the critical infrastructure. The role of the critical infrastructure resilience integration engineering is being described in 5 parts. An assessment of the context and culture of industry sectors. An assessment of the readiness to fulfill the intelligent middleman job description for each industry sector. An assessment of the resiliency maturity framework of industry sectors. Specify the critical infrastructure resilience system of systems architecture. Prepare a program plan for engineering, developing, integrating, and fielding the critical infrastructure resilience system of systems in terms of a way of working. Following a summary opening, I will discuss the current state and challenges of the critical infrastructure with particular focus on the dimensions of resiliency, critical infrastructure challenges, intelligent middlemen, maturity framework for assuring resiliency under stress, the model-based system of systems architecture that frames the solution, the integration program plan, and public-private partnerships. Resiliency is the ability to anticipate, avoid, withstand, minimize, and recover from the effects of adversity, whether natural or man-made, under all circumstances of use. Resiliency applied to a system of systems focuses on cross-cutting issues. Cross-cutting effects stem from dependent relationships. Some dependent relationships are planned and intended interactions between industry sectors, such as financial transactions embedded in telecommunications, electrical, transportation, and medical operations. Other dependent relationships are indirect and stem from outsourced commoditized services that bring with it opportunities for common single-point failures among industry sectors, such as the Internet, the Global Positioning System, Federal Express, IBM, and Microsoft. One respected researcher seemed to concede the high ground of resiliency, that is, avoidance, in associating resilience with the Timex slogan, "Take a licking and keep on ticking." The question then becomes, what perimeter is being secured? In protecting a network node or a physical facility in a geographic region, each node or facility is to be protected and made survivable. In achieving resilience, propagation and cascading effects across the network and region must also be curtailed. This is made difficult by the context and culture challenges of the industry sectors within the critical infrastructure. The capabilities needed to impact cross-cutting issues cannot be expected to evolve in a loosely coupled environment. They must be holistically specified, architected, designed, implemented, and tested if they are to operate with resilience under stress. A management, process, and engineering maturity framework is necessary to advance the assurance of software security, business continuity, system survivability, and system of systems resiliency capabilities. The critical infrastructure is composed of the numerous industry sectors that do the heavy lifting. Some key sectors are listed here. The operations within the industry sectors of the critical infrastructure are diverse and complex. These industry sectors comprise an accidental system of systems that intersect operationally without a plan and design in advance. Each sector system was constructed within its own context and culture. In operation, these sector systems may inadvertently impose their own context and culture on others and clash with uncertain and unintended operational results. Industry sector practice varies widely in their domain engineering approaches, resulting in diversity in architecture, models, and patterns, including their representation. Formality within an architectural framework facilitates the imposition of distributed supervisory control, interoperability, and operation sensing and monitoring protocols. Industry sector maturity in management and engineering processes varies widely, resulting in diversity in configuration management, frequency of release, conformance to requirements, and traceability among lifecycle artifacts. Strong code management practices facilitate reconfiguration and reconstitution. Industry sector practice varies widely in fielding and operating practices, resulting in diversity and accountability and control, supply chain management, civility and pushback, and willingness to expend off-the-clock effort. Exercising strong control over the workforce facilitates business continuity and survivability. Industry sector impacts from government regulation vary with respect to export control, tax policy, intellectual property, privacy, and antitrust litigation. Exercising strong government control facilitates compliance for the benefit of the commons at the expense of initiative for the self-interest. Industry sector public expectation and confidence vary with respect to trust, loyalty, and satisfaction. The financial and medical sectors depend on public trust. The electrical and telecommunications sectors depend on customer loyalty and satisfaction. The diverse industry sector expectations of trust, loyalty, and satisfaction must be respected, blended, and harmonized. Technical debt is the organizational, project, or engineering neglect of known good practice that can result in persistent public, user, customer, staff, reputation, or financial cost. In truth, most technical debt is taken on without this strategic intent, without even knowing it, and without the wherewithal and ability, capability, or capacity to do the job right. Technical debt must be eliminated. The following context and culture harmonization steps are called for. Formality within an architectural framework facilitates the imposition of distributed supervisory control, interoperability, and operation sensing and monitoring protocols. Strong code management practices facilitate reconfiguration and reconstitution. Exercising strong control over the workforce facilitates business continuity and survivability. Exercising strong government control facilitates compliance for the benefit of the commons at the expense of initiative for the self-interest. The diverse industry sector expectations of trust, loyalty, and satisfaction must be respected, blended, and harmonized. Technical debt must be eliminated. If the critical infrastructure is to be resilient, its sector managers and systems must respond to guidance from intelligent middlemen whose influence is felt before, during, and after a crisis. Intelligent middlemen possess the broad range of hard and soft skills spanning the cultural, ethical, legal, business, process, management, and engineering dimensions needed to meet the challenges of the critical infrastructure in anticipating, avoiding, minimizing, withstanding, and recovering from cross-cutting effects and to impede the emergence of propagating and cascading effects. The intelligent middlemen are positioned at the center of things and serve as the traffic cop for identifying and driving resolution of cross-cutting issues. From this vantage point, the intelligent middlemen are able to obtain superior situation awareness. For example, they ensure that recovery time objectives are coordinated, interoperability protocols are followed, distributed supervisory control functions are coordinated, and operation sensing and monitoring functions are applied. Beyond just the critical infrastructure, the Homeland Security Information Network shown here, begins to capture the broader demand for resiliency. Here we need to strike an intelligent balance between two extremes, where no one knows everything and where everyone knows everything. We need to adopt the intelligent middleman approach, where highly qualified middlemen know as much as possible, know how to acquire additional information, know how to connect the dots, and know how to act on what they know. Of the 36 entries comprising the communities of interest shown here, how many do you think are secure? Can anyone name one entry that is secure? Now consider the Homeland Security Information Network itself. To what extent is the network resilient? Just as important as the answer to the question is the means by which you arrived at the answer. How does one assess the assurance of resiliency? The intelligent middleman job specification is described as follows. Number 1, the intelligent middleman must be educated, trained, and in possession of the broad gauge experience to fill the role of Chief Critical Infrastructure Resilience Architecture and Operations Engineer. Number 2, as Chief Engineer, the intelligent middleman must be educated and trained in the prerequisite essentials of both systems engineering and software engineering, and have experience in how things are built and how things are used, from architecture through operations. Number 3, as a boundary spanner, the intelligent middleman must understand and be capable of planning and exercising command and control of the critical infrastructure under stress. Number 4, specifically, the chief engineer must manage the state transitions associated with its electrical grid and data transmission infrastructure, interoperability and information sharing protocols, cybersecurity framework, law enforcement and emergency services, sector coordinated recovery time objectives, cascade triggers, digital situation awareness, information and data recovery protocols, distributed supervisory command and control protocols, and supply chain logistics and risk management. Number 5, the intelligent middleman must maintain the foremost focus on the goal of anticipating, avoiding, withstanding, mitigating, and recovering from the effects of adversity, whether natural or man-made, under all circumstances of use. There exists a need for a means to harmonize the diverse and complex operations within the industry sectors of the critical infrastructure, which comprise an accidental system of systems that intersect operationally without a plan and design in advance. The maturity framework for assuring resiliency under stress provides that means and delivers value through management, process, and engineering capabilities and solutions that address security, continuity, survivability, and resiliency. The system perimeter focus areas include commitment to a business case, security in depth, business continuity, and survivability. The essential focus areas needed to extend this perimeter to the system of systems context needed to demonstrate resiliency include coordinated recovery time objectives, interoperable information and data exchange, operation sensing and monitoring, distributed supervisory control, and information and data recovery. To achieve maturity and the assurance of resiliency under stress, the enterprise must satisfy the goal-based argument at each level. The objective of the maturity framework for assuring resiliency is to drive the business case and enterprise commitment towards the assurance of software security, business continuity, system survivability, and system of systems resiliency. The systems of systems architecture and engineering operational concept underlying resiliency under stress is shown here. Interoperability, operation sensing and monitoring, and coordinated recovery time objectives form the foundation for digital situation awareness. Intelligent middlemen, response tactics, the identification of cascade triggers, and information and data recovery tactics form the ingredients for distributed supervisory control. A nation's critical infrastructure is composed of systems. Resilience in the critical infrastructure can be reasoned about using the systems coupling diagram framed by Harold Budd Lawson. The model is composed of a situation system, an interacting respondent system, and systems assets, instantiated for use as services as needed by the respondent system in its interaction with the situation system. The systems coupling diagram is a template and pattern for software systems architecture of all kinds. A resilient software system architecture based on the systems coupling diagram would be capable of delivering a resilient critical infrastructure system of systems. In accordance with the systems coupling diagram, the software systems architecture for critical infrastructure resilience calls for the allocation of control, function, persistent data, and assets. The architecture rules of construction associated with each factor are shown in the table. Intelligent middlemen in the situation system control the critical infrastructure sector transition from normal mode to shutdown, alternate site, or alternate mode, using the tools of the respondent system associated with digital situation awareness and distributed supervisory control. Critical infrastructure sectors perform their sector functions as part of the situation system, relying on the respondent system for operation sensing and interoperability. Persistent data is held and managed locally by the critical infrastructure sectors, relying on the respondent system for coordinated recovery time objectives, management and control of cascade triggers, and information and data recovery. System assets associated with security, business process continuity, and system survivability are accessed, instantiated, and consumed by the situation system and the respondent system. System assets performs no control, function, or persistent data actions. In accordance with the systems coupling diagram, the software systems architecture for critical infrastructure resilience calls for the following allocation of control, functions, and persistent data and assets. The situation system is populated with the man-made critical infrastructure sectors and the intelligent middlemen control node. The respondent system is populated with the Level 5 System of Systems Resiliency Engineering mission focus areas intended to interact with the situation system and its intelligent middlemen in anticipating, avoiding, withstanding, mitigating, and recovering from the effects of adversity under all circumstances of use. The system assets is populated with the Level 2 through 4 facilities focus areas and their services to be instantiated by the respondent system in its interaction with the situation system and its critical infrastructure sectors. More specifically, the critical infrastructure situation system is composed of utilities and energy, banking and finance, medical systems, transportation, and telecommunications, as well as public health, food and agriculture, federal agency, regional response, emergency response, and intelligent middlemen control node. Each sector of the situation system is composed of the control, functions, and persistent data and assets local to the sector. The respondent system is engineered as a system of systems architecture composed of coordinated recovery time objectives, interoperable information and data exchange, operation sensing and monitoring, digital situation awareness, distributed supervisory control, and information and data recovery. The situation system is composed of the control, functions, and persistent data and assets of the global system of systems. The system assets include services and facilities to be instantiated by sector, including enterprise security commitment management services, enterprise business continuity services, and system survivability engineering services. The system assets is composed of the facilities and service assets made available to situation system and its sectors by the respondent system. Whether you establish criteria at the beginning of a project or not at all, there exists industrial strength objective criteria for learning the status of a project and pointing the way forward. These criteria can be found in the Software Engineering Method and Theory, CMAT, formulation, and its essence kernel, the essence and common ground of software engineering, and a major object management group, OMG, standards process. The customer space is framed by a stakeholder shared vision for a well-conceived value proposition for the opportunity, with convincing and consequential outcomes. The solution is bounded by stakeholder agreed-to requirements and user stories, and a software system architecture that facilitates a usable and operational software product. The endeavor's work is performed by a well-selected and ready team, and a way of working based on established principles and foundations. As the twig is bent, so grows the tree. So to get your project off on the right foot, expectations should be set and evidence should be sought on the following assertions and principles based on the following alpha state checkpoints. Number 1, stakeholders are in agreement and share a vision for the project. Number 2, an opportunity value proposition has been established, and there is stakeholder shared vision for achieving it. Number 3, requirements or user stories are coherent and acceptable, and there is stakeholder shared vision for them. Number 4, the software system architecture is selected and comprises a domain-specific architecture to guide software system implementation, and the software system implementation is made ready and operational with no technical debt. Number 5, the team operates in collaboration, shares a vision for the project, and is ready to perform with respect to shared vision, software engineering process, software project management, software product engineering, operations support, and domain-specific architecture, processes, methods, and tools. Number 6, the way of working by the team has established foundations for software engineering process, software project management, software product engineering, and operations support. Number 7, the work is started only when all is prepared, including coherent requirements and acceptable user stories, stakeholders in agreement, and an established foundation for the way of working. Number 8, all work products are prepared and inspected in accordance with a defined standard of excellence, assuring completeness, correctness, and consistency. Certain selected milestone states serve as indicators of project success. When completion of these states and their stages is neglected or postponed, the outcome of the project is placed at risk. The figure presents the selected milestone states critical to success on a project. What is needed is a kickoff commitment for the critical infrastructure resiliency opportunity identified and selection of the team. Stage 1, pointing the way, has been initiated with requirements bounded and a software system architecture selected. Stage 2, digging in, is awaited with the need to articulate the value proposition for each industry sector, coupled with coherent requirements to deliver on it, and established foundations for the way of working. Stage 3, major milestones, with stakeholders in agreement, accepted requirements, and work started, by the team performing the initial release. Stage 4, locking in the gains, with stakeholders satisfied with deployment and the team performing incremental releases with work that is under control. Stage 5, preparing to stand down, with stakeholders satisfied in use, benefits of the opportunity value proposition being accrued, and the team working well in performing the final release. Project termination, with retirement of the project and work that is closed. The program plan for engineering, developing, integrating, and fielding the critical infrastructure resilience system of systems is presented here as a work breakdown structure for critical infrastructure resilience. Based on the clean room software engineering and CMAT essence kernel way of working. The challenge is to structure the software development plan as an incremental development with well-specified design levels and incremental releases, each with fine-grained cost accounts, formal software inspections of design-level artifacts, careful management and visibility of systems engineering to be determined items, and a relentless focus on the innovation needed to meet the challenges of resiliency. The overall demonstration of the mission to achieve critical infrastructure resilience is being initiated in several parts, including the composition of a user story, the subject of earlier work, the assessment of industry sector resiliency maturity, compatibility of industry sector context and culture, industry sector technical debt, and industry sector intelligent middleman readiness. Specification of the critical infrastructure resilience system of systems architecture, respondent system, and a program plan for engineering, developing, integrating, and fielding the critical infrastructure resilience system of systems respondent system in terms of a way of working. The state of the critical infrastructure resilience system of systems respondent system is shown here with the current state of progress in italics type and next steps underlined. Stakeholder has been recognized and awaits the individuals to be assigned to each industry sector as representatives. The opportunity has been identified and software is clearly needed. We await the value established in terms of a value proposition. Requirements have been conceived and bounded and found coherent. They need, as a next step, to be found acceptable. The software system architecture has been selected. The next step is to be sure that it's demonstrable. The team has been selected. The team is about to be selected, and we await that event. The way of working, principles have been established, foundations have been established. When the team is selected and begins, the way of working will be in use. The work has yet to be initiated, and that's the next step. The work product has yet to be identified and specified. The key to genuine and effective public-private partnerships is indemnification. To unlock the door to critical infrastructure resiliency, use the key labeled indemnification. Beyond an understanding of the critical infrastructure and its sector domains, the software and systems coupling architecture, and the software engineering way of working, the key to the critical infrastructure resiliency is indemnification that unlocks the value proposition and willingness for cooperation and sharing among all participants. The principles, foundations, and elements of integration engineering in the pursuit of critical infrastructure resilience set the table for research and practice and pave the way for the role of a critical infrastructure resilience integrator as follows. The harmonization of the context and culture of industry sectors in the critical infrastructure domain. The defined role and job description of the intelligent middleman as the traffic cop for harmonious cooperation among industry sectors. the order and utility of the focus areas in the resiliency maturity framework, the application of model-based systems architecture and the systems coupling diagram with its situation system, respondent system, and system assets in the critical infrastructure resilience system of systems architecture, along with specified architecture rules of construction spanning control, function, persistent data, and assets. The utility of the software engineering method and technology, CMAT, essence kernel way of working in bridging the gap between managers and technical practitioners among industry sectors in resilience integration program planning. The public policy imperative to enhance situation awareness through information sharing and unfreeze the impasse by indemnifying private industry sector participants. To what extent is there the political will to pursue a critical infrastructure system of systems based upon the following? Is there harmonization of context and culture? Is there capability readiness of intelligent middlemen? Is there advancement of resiliency maturity? Is there adoption of a system of systems architecture? Is there execution of an integration program plan? Is there advancement of public policy imperatives? So there we have the user story for critical infrastructure resiliency. Resiliency is the high ground. Claim it. Make your move. How many people are ready to take the next step? Here is my contact information. I would be happy to receive questions and have discussions with people on this important subject.